For this question, we are asked to construct a 99% confidence interval for the population mean number of years UM graduates work before being promoted. We are given the following values. Sample size N is 42. Sample mean X is 5.5 years. Sample standard deviation S is 1.1 years. The confidence level is 99%. Degree of freedom is sample size minus 1, which equals 41. From the T distribution table, the T critical value for 99% confidence and 41 degrees of freedom is approximately 2.695. Degree of freedom is sample size minus 1, which equals 41. From the T distribution table, the T critical value for 99% confidence and 41 degrees of freedom is approximately 2.695. Next, we calculate the standard error, which is SE equal sample standard deviation divided by the square root of sample size. That is SE equal 1.1 divided by the square root of 42, which gives approximately 0.1697. Now we compute the margin of error. E equal T times SE, that is 2.695 multiplied by 0.1697, which is approximately 0.4573. To find the confidence interval, we take the sample mean plus or minus the margin of error. So we calculate 5.5 plus and minus 0.4573. This gives us a confidence interval from 5.04 to 5.06. Therefore, at the 99% confidence level, we can say that the population mean number of years before promotion is between 5.04 and 5.96 years.
Assalamualaikum, I'm Syuhada and I'll be explaining about question 2. Starting with A, the question for A is what is the difference between a null hypothesis and an alternative hypothesis. So, null hypothesis is a statement of no effect or no difference that is tested for possible rejection. It also represents the status quo or default position. So, null hypothesis will always include an equality signs. The signs I've already included in the slide, so you can see how the signs look like. And then about the example, the average commute time is 30 minutes. So, I also provide the example for it. So, null hypothesis mu equals to 30. Moving on to alternative hypothesis is a statement that contradicts the null hypothesis. It represents what the researcher want to prove or suspect is true. Alternative hypothesis will never include equality. So it will use signs like not equal, more than, or less than. Then the example is the average commute time is not 30 minutes. As you can see in the slide, alternative hypothesis mu not equal to 30. Moving on to the next question, that is B. What is the difference between a one-tailed and two-tailed test? Starting with one-tailed test. One-tailed test used when we were specifically interested in a difference in one direction only, either greater than or less than. The alternative hypothesis were either, you can see the symbol there, it's more than or less than. Moving on to two-tailed test, used when we were specifically interested in any difference from hypothesized value without specifying direction. This alternative hypothesis used not equal sign. Alright, now we continue on question C, that is what is meant by a p-value. So the p-value is the probability of obtaining test result at least as extreme or the observed result, assuming the null hypothesis is true. A small p-value that is typically less than or equals to 0.05 indicates strong evidence against the null hypothesis. So we reach to the last question under question 2, that is question D. A hypothesis regarding the weight of newborn infants at IZRAF hospital is that the mean is 6.6 pounds. A sample of 7 infants is randomly selected and their weight at birth are recorded as 9.0, 7.3, 6.0, 8.8, 6.8, 8.4 and 6.6 pounds. What is the decision for statistical significant change in average weight at birth at the 5% level of significance? So before you jump into the calculation, you need to pull out every data that have given in the question. That is null hypothesis, alternative hypothesis, sample weight, sample size and also significance level. After you get everything listed out, and then you can do the mean. 9.0 plus 7.3 plus 0.0, everything under the sample weight will be divided with 7. And then you will get 52.9 divided by 7 equal to 7.55714 LBS. And then before we jump into step 2, you need to calculate everything starting from 9.0 until 6.6 minus with 7.55714 and then times with 2. And then you will get the 2.0816 plus 0.0661 plus 2.4245 plus 1.5437 plus 0.5735 plus 0.7102 plus 0.9162 equals to 8.3158. After that, it will be divided by n minus 1 equals to 6 and take the square root. So you will get s equals to square root 8.3158 divided by 6, and then you will get 1.177271 LBS. Alright, now we continue on step 3 for calculation for question D. That is standard error equals to standard sample divided with square root n. That is 1.177271 divided with square root 7. We will get 1.177271 divided with 2.6457. 45751, and then the answer for that we will get 0.444960 LBS. And then on step 4, we have the T, statistic T, equals to mean minus mu divided by standard error. That is 7.557142 minus 6.6 divided with 0.444960. We will get 0.957142 divided with 0.444960. And then the last answer is 2.1516, 06. So the final T statistics, T equals to 2.15. In the slides, I also include the distribution that I've drawn myself. So you can see how we get to the point 2.15. So the degree of freedom is n minus 1 equal to 6. Critical T value, that is 2-tail, alpha equals to 0.05, degree of freedom equals to 6. We will get the plus or minus 2.447. So the decision is, since 2.15 less than 2.447, we fail to reject null hypothesis. So there is no statistically significant evidence at alpha equals to 0.05 to conclude that the mean birth weight differs from 6.6 LBS. So basically 2.15 doesn't fall in the reflection region.
Question 3. A. List the 5 steps to perform hypothesis testing. Okay, first, state the null and the alternate hypothesis. Null hypothesis is H0, alternative hypothesis is H1. Second, state the level of significance. Common choice are 0.05, 0.01 and 0.1. Third, find the appropriate test statistic. Because we are comparing mean of more than 2, so we use the F statistic. 4 states the decision rule. Reject H0 if compute F is greater than critical F. And lastly, compute the value of F and make a division. If computed F is greater than critical F, we reject H0. If critical F is greater than compute F, we do not reject the H0. Then we state the conclusion in the context. Next B, the Ministry of Human Resources want to know whether the mean salary of worker in the fast food industry was larger than of the restaurant industry. To investigate, the industry collected the following information on the amount earned last week by a sample of workers in the fast food and restaurant industry. So that is the data that the question provides to us. At the 0.1 signification level, we can conclude that the mean salary are greater for the fast food worker than the restaurant worker. What is the p-value? Step 1. State the null and alternate hypothesis. H0 is mu fast food smaller than or equal mu restaurants. H1, we get mu fast food is greater than mu restaurant. Step 2. Select the level of significance. The 0.10 significant level is staged in the problem. Step 3. Determine the appropriate test statistic. We will use the t distribution. And step 4. Formulate a division rules. We can reject H0 if the compute t is greater than critical value of t. So degree of freedom is 11 and significance level is 0.10. So the critical value that we get is 1.363. Okay, we continue to step 5, which is compute the value of the test statistic and make a division. So first thing first, we must to calculate the mean for the fast food and for the restaurant. So what is the formula for the mean? The formula for the mean is sum all of a value divided by number of value. So the fast food, we get sum of all value is 855 divided by 6 and the mean is 142.5. Other than that, we also can calculate the sample variance. So what is the formula for the sample variance? The formula is a total x minus mean square divided by n minus 1. So how we get the total x minus mean square? We must calculate one by one like I show in the table. So the total that I get is 749.5. So we just take that and include in our formula. So then we get the variance for the fast food is 149.9. Let's continue to calculate the mean for the restaurant. So we use the same formula, which is sum of all a value divided by number of a value. So sum of a value for the restaurant is 912 divided by 7. So we get the mean is 130.29. So after that, we can calculate the sample variance for the restaurant. We use the same formula, which is I get the total for the x minus mean square is 1495.4287. So I divide by 7 minus 1. So I get the sample variance for the restaurant is 249.24. So lastly, we can determine the value of t because we already have all the data. So how we can determine the value of t? We can use the formula for t, which is mean for the fast food minus mean for restaurant divided by square root variance divided by n plus variance for restaurant divided by n. So the amount that we get is 142.5 minus 130.29 divided by square root 149.9 divided by 6 plus 249.24 divided by 7. So the t value we get is 1.57. After that, we can calculate for degree of freedom. So what is the formula for degree of the freedom? Degree of the freedom is n for restaurants plus n for fast foods minus 2, so we get 11. After that, we can find the t value. When t value is 1.57 and degree of freedom is 11, so 1 t value equals to 0.075. Next, conclusions. We can conclude that 1.363. For inside area of rejection, since p-value is 0.075 is smaller than significance value, so we reject H0. We can conclude that fast food worker earn more average than the restaurant worker. So p-value is between
10% to 5%.
An investigation of the effectiveness of a training program to improve customer relationships include a pre-training and post-training customer survey. To compare the difference, they conclude a post-training survey score and pre-training survey score. 7 customers are randomly selected and complete the survey. So the result is followed in the table. For a 0.05 significance level, what is the decision regarding the hypothesis that the training was effective in improving customer relationships? Step 1. State the null and alternate hypothesis. H0 is equal to mu t equal to 0. H1 is mu t greater than 0. Step 2. Select the level of significance. The 0.05 significance level is staged in the problems. Step 3. Determine the appropriate test statistic. We will use the t distribution. Okay, step 4. Formulate the division rule. So we get the significance level is 0.05. So degree of freedom is C. So we get the critical value is 1.943. Step 5. Compute the value of the statistic and make a divisions. Let D equals to post-training minus pre-trainings. So from that we can get a different. I already showed in the table, which is 2003216. So the different are we must use a D bar. What is a D bar? D bar is usually the difference between pair values. So we need to pick 2 plus 0 plus 0 plus 3 plus 2 plus 1 plus 6 divide by 7 and we get D bar is equals to 2. So now we can calculate the sample standard deviation for ST. So what is the formula for standard deviations? The formula for the standard deviation is square root total D minus D bar square divide by n minus 1. So how we get the total of D minus T bar square? We need to calculate one by one like I showed in the slides. First, 2 minus 2 square equals to 0. 2 minus 2 square equals to 0. 0 minus 2 square equals to 4. 1 minus 2 square equals to 1. 0 equals to
square equals to 4, 6 minus 2 square equals to 16, and 3 minus 2 square equals to 1. So from that, we can total up and we get 26. So we can use the 26 and include in the formula. So the standard deviation that we get is 2.08. So from that, after we get all the data, we can test statistic. We can use a T formula to get the test statistic, which is T bar minus 0 equals to ST divide square root n. So we fill all the data in the formula and we get the test statistic is 2.545. Critical value and deviations. Degree of freedom is 6. Critical value is 1.943. So we can make a conclusion where 1.943 falls inside an area of rejections. So we can reject H0 and we can conclude that the means are not equal.
We were given a partial ANOVA table with the following values: treatment degrees of freedom 2, total degrees of freedom 11, mean square for treatment 20, total sum of square is 500. Using this, I complete the table and perform the necessary calculation. To complete the table, I calculate the treatment sum of square, SS equal MS, multiply DF equal 20, multiply 2 equal 14. Then I calculate the error sum of square. Total SS minus treatment SS equal 500 minus 14 equal 416. The error degrees of freedom, total DF minus treatment DF equal 11 minus 2 equal 9. Mean square for error, 416 divide 9 and we will get 51.11. F ratio MS treatment divide MS error equal 20 divide 51.11 equal 0.391. For A, how many treatments are there? The F treatment equal K minus 1 equal 2, K equal 3 treatments. For B, what is the total sample size? The F total equal sample size minus 1 equal 11, N equal 12. C, what is the critical value of F? From F distribution table at 0.05 with 29 degrees of freedom, F 0.0529 equal 4.26. D, write out the null and alternative hypothesis. HO, null hypothesis, all treatment means are equal. H1, alternative hypothesis, at least one treatment mean is different. For conclusion, my conclusion is compare F values, calculate F equal 0.391, critical F equal 4.26. Since 0.391 smaller than 4.26, we fail to reject the null hypothesis. There is not enough evidence at the 0.05 level to conclude that the treatment means are different.
So I'll be explaining about question 4 now. Question 4 is about Jacob Lee is a frequent traveler between Los Angeles and San Diego. For the past month, he wrote down his flight times in minutes on 3 different airlines. The results are while he used Ghost, JetRed, and Cloud Train. I will mention about the flight times later. So we need to use the 0.05 significance level and the 6-step hypothesis testing process to check if there is a difference in the mean flight times among the 3 airlines. So the question asks for a 6-step, but since Dr. MUKHRIZ mentioned to use 5 steps in the class, so I'll be using only 5 steps. So starting with step 1, state the hypothesis, that is null hypothesis that equals to mu1 equals to mu2 equals to mu3. So alternative hypothesis, the means are not all equal. So moving on to step 2, select the significance level. It's already given in the question, that is alpha equals to 0.05. And then step 3, determine the test statistic. We will use the F statistic. So step 4, decision rule. At alpha equals to 0.05 with the degree of freedom 1 equals to 2 and degree of freedom 2 equals to 32, the critical F value is 3.30. We reject null hypothesis if the computed F more than 3.30. So I already included the sketch of the distribution. You can see it will be 3.30. Alright, now we will continue on step 5 for question C. As I mentioned before about the how many times, I already listed out how many times, that is Ghost equals to N1 equals to 14, JetRed N2 equals to 14, and then Cloud N3 equals to 7. And as you can see in the slide, I actually wrote down again about how many times Jacob used each flight. So then we're moving on to calculate group means. Ghosts were mean 1 representative for Ghost, and then mean 2 representative for JetRed, and then x3 represent Cloud. So mean for Ghost is 50.57, and then mean for JetRed is 52.14, and then mean for Cloud is 55.71. After you got all the mean for each flight, we can start calculate grand mean. So the grand mean is 14 times 50.57 plus 14 times 52.14 plus 7 times 55.71 will be divided with 14 plus 14 plus 7. Then the final answer we will get 52.14. And then after we get the answer, we can move on to sum of squares between, that is SSB. So SSB, 14 in bracket 50.57 minus 52.14 square plus 14 in bracket 52.14 minus 52.14 square plus 7 in bracket 55.71 minus 52.14 square, we will get 107.43. So now this is the continuation of the calculation before. We will start with sum of squares within, that is SSW. So for SSW, we will start with Ghost, that is sigma x minus 50.57 square equals to 51 minus 50.57 square plus 51 minus 50.57 square, all the way down to 48 minus 50.57 square. And then after all the calculation, you will get 364.86, and then we will continue with JetRed. So sigma x minus 52.14 square equals to 50 minus 52.14 square plus 53 minus 52.14 square, all the way until the last one, that is 50 minus 52.14 square. Then you will get 284.86, and then we continue with Cloud, that is sigma x minus 55.71 square equals to 52 minus 55.71 square plus 55 minus 55.71 square, all the way until you find 59 minus 55.71 49 minus 55.71 square, you will get 264.86. And then we will continue with total SFW. So we will get 364.86 plus 284.86, and then 264.86 we will get add everything up, and then we will get 914.58. Then we continue with the degree of freedom. df1, that is between k minus 1 equals to 3 minus 1, we will get 2. And then the df2 within, that is n minus k equals to 35 minus 3, we will get 32. And then we continue, we will continue with mean square, that is ms. MST between, how to calculate it? We use SSB over df1 equals to 107.43 divided by 2, we will get 53.715. And then for MSE, that is within, SSW divided by the df2 equals to 914.58 divided by 22, we will get 28.58. Now we reach to the last calculation under step 5, that is F statistics. So F equals to MST divided by MSE, we will get 53.715 divided by 28.58, we will get 1.88. So in this step, I also included the ANOVA table. You can see in the slide, the first row that is source between, within, and total, and then the second row that is sum of square. Under that, we have 107.43, 914.58, and then 1022.01. And then the third row, we have degree of freedom. We have 2, 32, and 34, and then it's a column. The fourth column, we have the mean square. So on the third row, we have the 53.715, and then the fourth row, we have 28.58. So the F, we get 1.88. So the conclusion is F equals to 188, less than 3.30. So F critical at alpha equals to 0.05. The decision is fail to reject null hypothesis. So no significant difference is mean, black times among airlines. That's it. Thank you.